Welcome to The Explainer. We're going to tackle a huge question today. How do you teach a computer, a thing that's all about logic and numbers, to actually understand our language? You know, the messy, complicated way we all talk. Okay, so think about this. You read a movie review online, and you just know if it's good or bad, right? You get the vibe instantly. But how on earth does a computer do that? I mean, it only thinks in ones and zeros. It's all about bridging that gap, getting our words into their world of numbers.
All right, let's dive right into this core problem. This clash between how we talk and how machines think.
You know, our language is just full of nuance. If I say, "That's sick," about a new movie, that's a good thing. But if I say, "I feel sick," well, that's obviously not. A computer doesn't get that difference, not on its own. It's all about pure, cold logic for them. So the real question is, how do we translate our flexible, context-heavy words into their super rigid language of numbers?
So, for a computer to do anything at all with our words, analyze them, translate them, whatever, it has to turn them into numbers first. It's kind of like how a computer sees a photo. It doesn't see a picture of a dog, it sees a grid of pixels, and every single one of those pixels is just a number.
Okay, so the first big idea to solve this was, well, it was really simple, super straightforward. But, and this is a big but, it had a massive flaw.
This first approach is called one-hot encoding. Just imagine you have a dictionary with every single word you can think of. To represent the word cat, you'd basically create this huge, long list of zeros, 1 0 for every word in that dictionary. And then you'd find the spot for cat and just flip that 1 0 to a 1. That's it. It's like giving every word its own unique little on-off switch. Seems logical, right? But it's got a huge blind spot.
And here is the fatal flaw. Using this method, the distance mathematically between cat and kitten is exactly the same as the distance between cat and car. Think about that. To the computer, a kitten is just as different from a cat as a car is. This whole approach just completely misses what the words actually mean.
So to fix this huge problem, researchers came up with a totally revolutionary idea, an insight that changed everything about how machines learn to understand us.
The breakthrough was this pretty profound idea from back in 1957, and it boils down to this. You know a word by the company it keeps. A word's meaning isn't really in its dictionary definition, it's in the other words that always show up around it, right? We know what coffee is because it hangs out with words like cup, hot, and morning. Context is literally everything.
So how does a computer actually do that? Well, first, it scans a ridiculous amount of text. We're talking all of Wikipedia, for example. Then it starts counting. It builds this giant chart, tracking how often certain words appear next to each other. And finally, it uses some seriously heavy-duty math to analyze all that data and find all the hidden patterns and relationships between words.
And this whole idea, this focus on context, leads us to a much smarter way of turning words into numbers, a way that actually gets the relationships between them. And that solution is called a word embedding. So instead of that simple on-off switch from before, now every word gets a whole list of numbers, say 300 of them. You can think of it like a rich, complex numerical fingerprint. Each number in that fingerprint represents some different aspect of the word's meaning, all learned from analyzing tons and tons of text. It captures what a word is really all about.
And there are specific models, you might have heard of them like Word2Vec and Glove, that are built to create these amazing fingerprints. They do it slightly differently, but the end result is the same. And here's where things get, well, honestly, kind of mind-blowing. Once you have these meaningful numbers for words, you can start doing math with them, like word algebra.
Okay, let's walk through the most famous example of this word algebra. We're going to start with the numerical fingerprint for king. Now, from that, we're going to mathematically subtract the fingerprint for man.
And then we're going to add the fingerprint for woman. So we have king minus man plus woman. What do you think that equals?
The result is a set of numbers that is incredibly close to the fingerprint for the word queen. Isn't that wild? This shows that the computer has learned these really abstract concepts, like gender and royalty, without anyone ever explicitly teaching it. It just figured it out by looking at the patterns in how we use words.
So this word algebra thing, it's way more than just a cool party trick. It's actually the engine that powers a ton of the technology you and I use every single day.
Remember that whole movie review question from the beginning?
That's called sentiment analysis, and this is how it works. But this technology is also behind machine translation, chatbots, all those virtual assistants, and something really powerful called semantic search. That's searching for meaning, not just matching keywords.
Let's take a look at how that actually works in practice. So imagine you're on a movie site. You don't have a specific title in mind, you just know the kind of movie you're in the mood for. So you type in something like this.
Now, check out the top result it gives you. Notice how it doesn't actually contain the words action movie or car chases. Instead, it says high-octane films and thrilling vehicle pursuits. A normal old-school keyword search would have totally missed this, but semantic search, it understood the meaning behind your words and found a perfect match.
And this really works. When you build a model using these exact techniques to classify those movie reviews, as good or bad, it can be right up to 87% of the time. That's incredibly accurate.
So, this ability for machines to grasp not just our words, but the complex tapestry of meaning woven between them, it's completely changing how we interact with technology. And it leaves us with one heck of a final thought. If we've already taught machines to understand the meaning behind our words, what on earth will they understand next?